Okay, physics. So we're going to get into different, I guess, forms of energy. So it's important to remember that energy can be stored in different places, and we can move it around between different places. And this is I think, going to be our first example of moving energy around. So in this case, I've got a cart that's attached to a mass. So this is a half Atwood machine. And I'm going to start this in slow motion. Let's just watch what happens. So I release the cart, and notice what's happening. So I have a force that is being applied over some distance, and my cart ends up having some motion, right? And eventually it all comes to a stop. So the important thing is, right, so what did I do? I gave some motion to the cart. So we're in energy of motion now. So kinetic energy, we're going to describe that a little bit. We're going to have two flavors of kinetic energy. We'll get into one now and one when we get into rotation. But notice what I did. I did work on this. So work is the way that we put energy into something, and specifically in this case, I'm putting kinetic energy into this cart by applying a force over some distance. So let me play this again for you, and a couple of important points I want to make. So I'm going to start this. So notice this force is the tension, but this is accelerating, so tension is not going to be equal to mg acting on this mass. So go back and think about half Atwood machines and why that's the case. So some of that force that's coming from gravity is going to be consumed by accelerating this mass, and not all of that force is going to be transmitted into the string. If it was stationary, it would be. Anyway, so these are the connections that we're going to try to make. So we're going to get into kinetic energy and how work is connected to that. So briefly, so kinetic energy is the energy of motion. So we'll use capital K, sometimes KE, mostly K. And we describe that as this formula, so it's 1/2 mv squared. So something has to have velocity. And notice we're squaring velocity, right? So it doesn't matter if velocity is negative or positive, so that kinetic energy is always going to be positive. So energy in general is always going to be positive. So to give you some feel for this, the house flying flight is 10 to the -3 joules of kinetic energy. Car traveling at 60 miles an hour is going to have around 10 to the 6 joules of kinetic energy. So the thing that we're going to do, so notice what we did. So that work that I did ended up putting energy into the cart. So if there's no friction, that all of that energy of the work is going to be transferred into the kinetic energy of the car. So more formally, what we're going to say is that in the absence of friction, that work is going to equal that change in kinetic energy. So notice I'm saying change in kinetic energy. So I started from 0 in this case, so it started from rest. So my initial kinetic energy, where velocity is 0 means I have 0 initial kinetic energy, but that work is going to be the change in kinetic energy. So this is important when we get to signs. So remember, kinetic energy is always going to be positive. I'm going to find the difference of my two kinetic energies here, and that must be how much work I did. So we'll be connecting these two a bunch. So a brief mention about signs. So remember, work is not a vector, but it does have a sign. So remember, positive work means I'm adding energy into it, and negative work means I'm taking energy out of my system. So I'm going to be careful. So kinetic energy never has a vector. It's always just a quantity. It doesn't have a direction, and it's always positive. So work can be the change in kinetic energy, and I can lose kinetic energy, right? So if I'm slowing down a car, I'm doing negative work on that. So I'm taking energy out of that, right? And my kinetic and my velocity afterwards is less than my velocity beforehand, and I'll have less kinetic energy, therefore a negative change in kinetic energy. Key things to think about. So these are the things to remember about the sign. That work is going to be positive. Kinetic means kinetic energy is increasing. And if work is negative, it means kinetic energy is decreasing. And of course, total work is 0, then nothing's going to happen. So if I have something going at constant velocity, I may be putting work into it, right? But something's taking work out, right? So if I have a box I'm pushing across the floor at constant velocity, I'm adding energy into the box, but that energy is being lost to friction in the box, so it can have no net gain in work. So a lot of times we'll worry about the net work, not the computer system network, but the net work that's being done on a system, and we need to take into account energy is being lost and energy is being gained. And if energy is being lost, it's usually in this class is going to be through friction or drag. Anyway, I hope it's helpful. So this is one of those equations which doesn't show up, but I kind of expect us to remember it, that work is equal to the change in kinetic energy. And really useful. It's really the only way that we can get energy into a system in this class is through doing work. Hope this is helpful. Talk to you soon. Bye.